student, you're welcome to your favorite educational program, Teaching and Learning on Radio by Niger State Ministry of Education. It promises to be interesting and it comes up every weekday. This is to keep the school children abreast of their curriculum due to coronavirus pandemic that has kept them at home. At this moment, we have our facilitator in the studio who will be taking you on a very interesting subject. Happy viewing. I am Kabir Yusuf.
Today we are going to look at mathematics for SS1 students. And the topic we are going to look at today is set. What is a set? Before we define set, we are expected to know the following at the end of this lesson. 1. Define set. 2. Use set notations. 3. Identify types of sets. Now, what is a set? A set is a collection of a well-defined objects. These objects can take various forms, like living and non-living things. The objects we refer to here are called elements. The element can be anything, that is, numbers, items, words, etc. And they are usually displayed inside a pair of matching braces or curly brackets. Example of sets include a set of telecommunications operators in Nigeria or a set of brand cars. When we talk about set of telecommunication operators in Nigeria, we mean set of operators like MTN, Globacom, Airtel, Nine Mobile. This is an example of a set. So having defined set as collection of a well-defined objects, and also we said those objects are called elements, and the element can be anything like numbers, items, word. We are going to look at what we call set notation. Set notation. When we talk about set notation, we mean what we name sets with. Sets are usually denoted by capital letters, such as capital letter X, Y, Z, A, B, C, etc., while the elements are usually denoted in small letters. For example, we have small letter A, small letter B, small letter C, small letter D, etc. Element is represented by the symbol E. Element is represented by the symbol E. And when we talk about element, we mean membership. We mean membership. So for example, if you have set A and set X, if we have set A that has elements small letter A, B, C, and we have set X that has elements small letter A, B, C, D, E, then we say that those elements in A are member of X. We write it as A is an element of X. That is, items found in a given set are referred to as element. So if we have A as a member of X, if A is not a member of X, we write it like this. We write A, then we cross that element sign, then we write X. That gives us A is not a member of X. That is, A is not an element of X. Set can be described in 4 ways. The first way in which we describe set is by word description. The second way is through listening. The third way is stating a rule. And the last way is through diagrams. We are going to take a look at them one after the other. We can describe a set through word description. What we mean by word description here is, for example, a set of students. If a set of students is given as S, then when you list those students found in that set, we refer to as description of set, because we are trying to describe that particular set which has student as its element. Then the second way which we can describe set is through listening. Example of listening is when you have a set of odd numbers greater than 50 or greater than 60. That gives you an example of how we describe a set through listening. The next one is by stating a rule. When you state a rule, you have example like all numbers divisible by 3, or numbers divisible by 2, or number divisible by 5. They are examples through which we can describe a set. Then the next one we said is diagram. Example of diagram is what we call Venn diagram. And when we talk about Venn diagram, we mean a diagram that has a shape of oval, like egg shape is a representation of Venn diagram. So we use it to describe a set. So what we are going to look at next, listeners at home, is types of set. We are going to look at types of set. And the first type of set we are going to look at is equal set. The next type we are going to look at is empty set. The next type of set is equivalent set. Equivalent set. The next type of set is finite set. The next one is infinite or infinite. Infinite set. The next type of set is universal set. Universal set. The next type of set we are going to look at is subset. We said the types of set include the equal set, the empty set, equivalent set, finite set, infinite set, universal set, and subset. Now we are going to take a look at them one after the other. The first one, which is equal set. Two sets are said to be equal if they contain the same element. The notation for equal set is the equal sign. That is the equality sign. That is what we use for equal set. And we said two sets are equal if they contain the same element. Remember, we said elements are those items we found in a given set. So if, for example, we have set A with element 2, 4, 6, and 8, and we have set B with element 4, 6, 2, and 8. Then we said that A is equal to B because they have the same number of elements in A and the same number of elements in B. So if they have the same number of elements, therefore we said A is equal to B. If you observe, set A has element 2, 4, 6, and 8. And set B has also element 4, 6, 2, and 8. If you look at it, they all have the same element, but the order of arrangement is different. So once you find yourself in this situation, then the two sets are equal. That is, the number of A is 4, and the number of elements in B is 4, so they are all equal sets. The next type of set is empty set. And from the word empty, when we say empty, we mean nothing is there. So a set that contains no element is called an empty set. A set that has no element is called empty set. And this empty set can also be referred to as a null set or a void set. That is the other names we give to a empty set. And we have these two symbols for empty set. This first symbol is called null, and when you have a curly bracket without an element inside, is for empty. So that means two symbols we use for empty set is for null and the empty or curly bracket. So whenever you see these two symbols, they represent empty set. Example of set that is empty is when you have a set that contains human being with two heads. Have you ever seen a human being with two heads? If it is no, then that set is an empty set. Another example of an empty set is months that begin with K. Do you have any month that begin with K? No. So if you don't have, it's an example of empty set. That is when we are classifying the set according to the month. The next type of set we are going to look at is equivalent set. Equivalent set. We say two sets, let's say set A and B, are equivalent if there is one-to-one corresponding between the elements in the two sets. That is, if both have the same cardinal number. What we mean by cardinal number is number of elements in a given set. That is what we mean by a cardinal number. So two sets are said to be equal if the number of elements in the first set is equal to the number of elements in the second set. Then we say the two sets are equal. For example, if you have a set A that has boy as element, girl as element, and man as element, then you have set B that has the following elements A, B, and C. When you look at set A, the number of elements we have there is 3. 1, 2, 3. And the set B has also 3 elements. Therefore, we say that A is equivalent to B. That is all about set A. So that's all about equivalent set. Number of elements in A, which is cardinal number, is equal to the number of elements in B. The next type of set we are going to look at is finite set. And when we talk about finite set, we mean a set that its elements are countable. That is what we mean by finite set. If we have a set and all elements there are countable, then that type of set is called finite set. Example is when we have a set of local governments in Niger State. You know, we have 25 local governments in Niger State. So if we can count those elements in that set, then we say to that set to be finite set. The other one we are going to look at is infinite set, which is the opposite of finite set. When we talk about infinite set, we mean that set that its element is uncountable. Finite is countable, infinite is uncountable. Example of infinite set is when you have a set of sand in a bag. Can you count sands in a bag? No. Since we cannot count it, it becomes infinite. Another example of infinite set is natural number. When you have a set of natural number and it's not specified. Remember we said natural number are a set of counting numbers from 1 up to infinity. So if it is not specified, that set is infinite. The next type of set we are going to look at is universal set. Universal set. From the word universal, we take out universe. When you say universe, it covers everything. That is what we mean by universal. So when we talk about set or universal set, we mean the umbrella set. That is the set that gives birth to all other sets. That is what we refer to as universal set. A set that contains all elements under consideration is called the universal set. We have two symbols for universal set. We have U for universe and we have E for entity. The two symbols are used to represent the universal set. U for universe, then we have E for entity. These two symbols, whenever you see them, they are used to denote the universal set. And we said the universal set represents the set that contains all other sets, or the umbrella set that gives birth to other sets. Example of universal set. When we have all states in Nigeria, and we decide to pick some state from a particular region, let's say from North Central. We have Niger, Benue, Kwara, Kogi. So by the time we take it out of the state in Nigeria, we have taken it from the mother set, which is Nigeria. The whole state make up Nigeria. By the time we take a segment out of it, the one we are taking out is an element. The one that give birth to the element is referred to as the universal set. So we said that when we take 2 states or 3 states from the whole state in Nigeria, we have we have taken from the universal set. So the last set we are going to look at, but not the least, is what we call subset. And when we talk about subset, we mean a set X is said to be a subset of another set B if every element in X is contained in B. Subset means set within another set. That is what we refer to as subset. For example, if you have set A with element 1, 2, 3, 4, 5, 6, and you have set B with element 1, 2, and 3. When you look at set B, we have elements 1, 2, 3, and when you look at set A, we have element 1, 2, 6. So being that B is taken from A, we said that B is a subset of A and is denoted by a symbol that looks like C. So we write it as B, a subset of A. This subset is divided into 2. We have what we call proper subset and we have what we call improper subset. So for you to determine proper subset and improper subset, you need to determine a subset. Let's take this example. If you have set X with elements 9, 10, and 11, for you to get the subset of X, you are going to bring the set outside one after the other. 1 is 9, the other subset is 10, then the next one is 11, then you take them 2, 2. The next one will be 9 and 10. The next subset will be 9 and 11. The next one will be 10 and 11. The next subset will be the empty set and the original given set itself. So each set is a subset of itself. And in every subset, we are going to have an empty set. So by the time we have these 8 subset in a given set which has elements 9, 10, and 11, we are going to take out what we call the proper subset and the improper subset. So by the time we take the original subset, the original set which is 10, 9, 10, and 11, and we take empty set, we have what we call improper subset. By the time we take the original given set and the empty set as a subset, we have what we call proper subset. By the time we take out these 2, all other ones remain improper subset. Listeners at home, I hope you are following. The next type of set we are going to look at is power set. A power set is a collection of all subsets in a given set. And we have this formula, 2 to the power of n, that we use in determining a power set. If we have a given set with elements 9, 10, and 11, the power set there will be 2 to the power of 3, where n represents the number of elements we have in a given set. So far, so good. We've been trying to look at the topic set. And from there, we start with what we call definition of set. We look at set notation and we identify types of set. Where we say a set is the collection of a well-defined object, and we went ahead and look at set notation. And we said set are denoted or represented with capital letter, while elements are denoted with small letters. And from there we look at how we can describe sets. And we say we have 4 ways in which we describe sets. One of it we said by word description. The second one we say through listening. The third one we say by stating a rule, and the fourth one we said we have through diagrams. From there we also proceed to the types of set, where we say we have equal set, empty set, finite set, infinite set, universal set, subset, and power set. Listeners at home, get your biro and try this exercise. Question 1. Let A be a set with the elements C, D, E, and F. A. List all the subsets of A. B. How many subsets does A have? I repeat again. Let A be a set with elements C, D, E, and F. A. List all the subsets of A. B. How many subsets does A have? Question 2. Give one example of each of the following sets. 1. Empty set. 2. Subset. 3. Power set. 4. Universal set. You can reach us on our WhatsApp number for more information and questioning. 09029282040. Again, 09029.
Believe you had a wonderful time listening to your favorite educational program, Teaching and Learning on Radio by Niger State Ministry of Education. The essence of the program is to educate our children that have been at home due to coronavirus pandemic ravaging the entire world. This program will come your way next time. We do hope you will join us. Kabir Yusuf is my name, and I'm thanking you for watching.